Hey guys, welcome back to my channel Alpha Geeks. So first thing first, if you want any assistance for mathematics related, any subject, any topic, or you are stuck with any of the problems, you can always contact me on my WhatsApp number or the email ID provided in the description link. If you want any online assistant from 5th standard to higher education or for any competitive or aptitude exams, you can contact me. Cool. Now let's start with today's topic. So let's go ahead. Today's topic is speed time distance. Speed time distance is one of the important topic in the competitive exams and the aptitude test which you need to solve it. These are the sums which you can get it very quickly and very easily. So let's revise our fractions first and then go to the theory of speed time distance. Fractions. So always remember fractions. Always. 1 by 3, 1 by 7, 1 by 9. 1 by 9 is 11.11. 1 by 11 into 100 is 9.09%. 1 by 2, 1 by 4, 1 by 14, 1 by 18. Always remember these fractions. By heart all these fractions which will be very useful in your calculations. Let's go ahead with the theory content of speed time distance. So concept, what is speed? Speed is basically tells us how fast or slow an object is moving. How fast and slow the object is moving defines the speed of the object. It describes as the distance traveled by the object divided by time taken to cover that distance. So basic formula of speed is equals to distance upon time. So basically the unit of speed will be the unit of distance per the unit of time. So if the distance is in kilometer and time is in hour, the unit of speed will be kilometer per hour. And if the distance is in meter and time is in second, then the unit of speed can be meter per second. This equation shows us that speed is directly proportional to distance and inversely proportional to time. So remember this thing, because sometimes in numerical we are asked to directly proportionate the distance and the time given. So speed is always directly proportional to the distance and inversely proportional to the time. Let's go ahead. So first example. So let's see our first example and learn how to solve the speed time distance numericals. What is the distance covered by a bus traveling at the speed of 30 km per hour in 20 minutes? Cool. Now the speed of the bus is given as 30 km per hour and time is given as 20 minutes. So we have two parameters. We have to find the third parameter. We know that speed is equals to distance upon time. So what will be distance? Distance will be speed into time. Now here speed is given in kilometers per hour and time is given in minutes. So first we need to convert those minutes into hours. So by dividing 20 minutes by 60, we can convert the term 20 minute into hours, because we know that 1 hour is equals to 60 minutes. So 20 minutes will be equals to 20 by 60 hours. Then we can substitute that into the equation up here. So the speed is 30 and the time taken is 20 by 60 hours. So the total distance after the calculation will be 10 kilometers per hour. So this is important. Always realize the units of the questions. The speed unit, the time unit, or the distance unit should be the same. You have to convert those units into the same units of the respective parameters. Let's go to our next example. Okay, before coming to our next example, there are some important conversions. Always remember these conversions. These conversions are very important while solving the numericals. Like 1 kilometer is equals to 1000 meters, 1 meter is equals to 100 centimeter, 1 hour 60 minutes, 1 minute is 60 seconds, 1 hour is 3600 seconds. Okay, now anytime you need to convert kilometer hour into meter second, just multiply that term by 5 by 18. If you have 90 kilometers per hour and you have to convert it into meter per second, so the 90 term into 5 by 18. So 18 fives are 90, and that will give you 25. So that is 25 meter per second. And if you have to reverse it, if you have to convert meter per second into kilometer per hour, you just have to multiply that term by 18 by 5. Getting it? Okay. Now let's move to our second example. Okay, let's start with example number 2. Let's read the question. Walking at three-fourths of its usual speed, Rahul reached his destination 10 minutes late. Find its usual time taken and the time taken to reach at its current speed. So here we don't know the parameters, the distance traveled by the Rahul, or the speed of the Rahul, or the time taken by him to reach the destination at his usual speed. So let's assume, since the destination and the starting points are same, we can assume the speed and the time taken by Rahul to reach the destination. So let's assume that his usual speed be x kilometers per hour and the time taken by Rahul must be t hours. Okay. Now, according to the condition, walking now the Rahul is walking at three-fourth of its usual speed. So his speed on this occasion will be 3 by 4 time of x. That will be 3x by 4 kilometers per hour. Now, the time taken on this occasion is how much? T plus 10 by 60 hours. Now, how come this? T hours is his usual time, and he is taking 10 minutes more at his current speed. So, we have to convert this 10 minutes into hours because we have assumed x in kilometer per hour and t in hours. So, converting 10 minutes in hours will be 10 by 60. So the time taken will be the 10 by 60 term will be added to t will be the total time taken by Rahul at 3 by 4th of its usual speed. Now let's move to the next thing. Since the distance travel on the both occasion is same, the starting point and the ending point in both the scenarios are same. Therefore we can equate the distance. Distance is equal to speed into time. So multiplying speed and time will give us distance. So at his usual speed he is covering x into t distance, and at his current speed he is covering 3x by 4 into t plus 10 by 60 distance. So these both the distances must be same because the starting and the destination are same. Now solving this equation we can get t equals to 2 by 3 hours. Now converting this hours into minutes will give us 40 minutes. Just multiply the term by 60 and you will get in minutes. And the time taken on this occasion where Rahul is traveling at 3 by 4th of his usual speed is 10 minutes more. So we have to add 10 in 40 minutes to get the time required if Rahul is moving at his 3 by 4th of the usual speed. So 40 plus 10 will give you 50 minutes. So at this occasion Rahul will take 50 minutes, and at his usual speed he takes 40 minutes. I hope you have got a basic idea on how to solve speed time distance. This was just a basic introduction on speed time distance. Detailed questions and more advanced topic and numericals will be covered in the later slide. This is for those guys who don't have any idea how to solve speed time distance, how to go about a sum, what is the concept of the speed time distance. You can go through the slides and like rewind the video if you are not understanding, or you can contact me on the information provided earlier. I will help you out. So thanks for watching guys. Thank you. Bye.